Every single time you move your mouse, or click to open a file, or even just connect to the internet, there's this silent guardian working in the background. It's your operating system, and it's running this constant, really complex security check on absolutely everything you do. So today, we're going to pull back the curtain and see exactly how that guardian works.
Just think about it for a second. It's something you do every single day. You type in your password, you hit enter, and bam, your desktop appears. But what's really going on in those few milliseconds? What kind of secret handshake is happening between you and your computer to grant you access? Well, let's solve that little mystery.
So, how does this all work? Well, your operating system, your OS, is basically a master juggler. It's constantly managing 3 huge tasks at once. It's managing resources like memory, it's scheduling which programs get to run and when, and this is the big one for us, it's controlling access. That security function is the whole reason one program can't just go in and mess with another, and it's what keeps your personal data safe.
Okay, so it all starts right at the front door. Before the OS can possibly decide what you're allowed to do, it has to figure out one crucial thing, who you are. And that's the job of our digital doorman.
Now, in the language of the OS, you're not just a user. You're what's called a security principal. It's kind of a technical term, but it just means anything the OS can reliably identify. That could be you, it could be another computer on the network, or even a group like administrators. The rule is super simple. If the OS can't prove who you are not getting in. Period.
All right, now here's where it gets really interesting. That username you type in, J Smith or whatever, that's just for you. It's a convenient label for us humans. The computer, it doesn't actually use it. Internally, the OS knows your account by a completely different, totally secret code. And that secret code is called a security identifier, or a SID for short. This long string of numbers is your true identity as far as the system is concerned. It is absolutely 100% unique. And get this, even if you delete an account, that SID is never, ever used again. It's like a permanent digital fingerprint.
What's so fascinating is that a SID isn't just some random number. No, it has a very specific structure. You can actually see it here. It's got a revision number, an authority that created it, like your local machine, and then at the very end, this thing called a relative identifier, or RID. That's the part that's totally unique to your account. This whole structure is what guarantees that it's absolutely one of a kind.
Okay, so you've logged in, you've proven who you are, and the OS knows your true identity, your SID. Now what? Well, it would be a huge pain if you had to prove your identity over and over again for every little thing. So instead, the OS gives you something like a temporary passport that's good for your entire session.
This digital passport is called an access token. The second you successfully log in, the system creates this token and just stuffs it with all your security info, your personal SID, the SIDs of any groups you belong to, and any special privileges you might have. From that moment on, a copy of this token gets attached to every single program you run. It follows you everywhere.
So here we are at the final step of the puzzle. You go to double-click a file. The program you're using to open it has your access token, your passport, attached. How does the OS make that final call yes or no? How does it check your credentials against that file's specific permissions?
It uses something called an access control list, or an ACL. The best way to think of it is as a very specific guest list that's attached to every single file and folder on your system. This list is just a bunch of entries that say things like, this SID is allowed to read this, or this other SID is explicitly denied from writing to this.
And here's the moment it all comes together. The OS takes all the SIDs from your access token and starts comparing them against that file's ACL, one entry at a time. Let's look at Andrew in thread A here. The very first entry the system finds for him is access denied. And that's it. Game over. The check stops right there and he's denied access, even if some later rule might have said yes. In this world, a denial always wins.
Okay, I know. SIDs, tokens, ACLs, it can all feel a little bit abstract, right? So let's bring this down to earth. How does this whole system actually protect you from a real-world threat, like a computer virus?
Here's the most crucial point to understand. A virus is just another program, another process, and when it runs, it inherits your access token. That means it is stuck with your permissions. So if you're logged in as a standard user, your token doesn't have the power to delete critical system files. And guess what? Neither does the virus.
It's literally trapped by the limits of your own identity. You see, this entire security chain we've just walked through, from your SID to your token to the ACL, it all hinges on that very first step, proving who you are. If a bad guy guesses your password, they get your access token, and with it, all of your permissions. That's why having a strong, non-guessable password isn't just a casual suggestion, it's the absolute foundation of your system's entire defense.
But, good security goes way beyond just passwords. There's this whole practice called system hardening, which is really just about layering your defenses to make an attacker's job as difficult as humanly possible.
And what's cool is that over the years, managing all these security settings has gotten so much easier. I mean, what used to be buried in these super complex policy editors, like the one from Windows Server 2003 you see on the left, is now handled in much more friendly dashboards. But even though the interface has changed, the core principles of controlling access, they are exactly the same.
So what are some of the key moves to harden a system? Well, first, you want to reduce the attack surface. Basically, if you don't need a program or service, turn it off. Second, use the tools the OS already gives you, like firewalls and security policies. Third, check your work. Audit your system regularly to find any weak spots. And finally, and this is a big one, remember that security is also a human issue. Training people to be security conscious is absolutely essential.
And that really brings us to a crucial final thought. This system is incredibly powerful, there's no doubt about it, but its own complexity can also be a weakness. A single misconfiguration, just one tiny mistake in an ACL somewhere, can create a massive security hole. It's a constant balancing act between having all this power and being vigilant enough to use it correctly.
And so, we're going to end with a big question. This model of SIDs, tokens, and ACLs, it's been the bedrock of OS security for decades. But now, in a world that's moving to cloud computing and these zero-trust networks where identity is absolutely everything, how will these old-school ideas need to change and evolve? What is the next generation of our unseen guardian actually going to look like?